The unit we're starting now is going to be all about exponential functions and what we call logarithmic functions. Before we start talking about logarithmic functions, we're going to focus a little bit on exponential functions. When we look at linear functions, we look at functions that increase or decrease at a constant rate. We've also looked at quadratic functions, which increase or decrease much more rapidly because when we are squaring larger quantities, we're going to result in bigger jumps between our y values. Now we're going to look at exponential functions. When we look at exponential functions, we are going to have a base that is a number, and we're going to raise it to a variable, which means we're going to be able to plug in numerous quantities for that variable, both very small and very large. So if you think about the jumps that we made with a quadratic function, as we plug in very large numbers for x, we're going to make even bigger jumps. So we say that it grows, or it decreases or decays exponentially. We will also be plugging in very small numbers, which are going to cause some asymptotes for us, because as we plug in very small numbers, and I raise things to the power of, say, 0.2 or 0.1 or 1/2 or 2/5, I'm going to get very small answers back. When we look at exponential functions, they are always going to be in this form here, where we can always have a coefficient. It's not necessary. Our coefficient could be 1 times our base raised to some power. A cannot be 0, B has to be greater than 0, but B cannot equal 1. We'll have both exponential growth and exponential decay. Exponential growth is going to be, if I look at what the function would look like, I would start out very small, and I would rapidly grow very large, again, because I'd be plugging large numbers in for my x. When I have exponential growth, my base, my b value, needs to be greater than 1. My greater than symbol is kind of bad there. When I have exponential decay, I'm going to instead start out very large, and I'm going to rapidly decrease, or I'm going to decrease down towards 0 and have, like I had mentioned before, that horizontal asymptote. It is decay when my decay factor, when my base is between 0 and 1. We're going to look at these 3 examples. All we're going to do is determine if they're exponential growth or exponential decay. We'll tell either what the growth, and I should have had in here, the growth or the decay factor is, and then we're going to sketch a graph. So I'm going to pause the video here quick, and I'm going to add in to each of these 3 pieces what I'm looking for. Okay, so on the first one, I look for my base to determine if it's growth or decay, and I see that my base, the thing that's being raised to the exponent, is 3. Since my base is greater than 1, I'm going to go ahead and say that that's a growth or an exponential growth function, and it's going to have a growth factor that I'm going to call the GF of 3. So if it's growth, it will look something like this. On the second one, again, I'm going to look at my base, the thing that's being raised to the exponent. Since my base is larger than 1, again, I have an exponential growth function with a growth factor of 7. And again, because it's growth, it's going to start with that horizontal asymptote and rapidly increase. Finally, the third one here, I look at my base. Because my base is between 0 and 1 when it's 1/3, I'm going to go ahead and say that this is an exponential decay function, and my decay factor is 1/3. And so I will start large, and I'm going to decrease down towards 0, again having that horizontal asymptote. One other thing we need to look at is what we call E. E is going to be a letter that's going to be used to represent a number. It's very similar to pi. Pi represents 3.14. E is going to represent 2.718. We use E to write a very special exponential function. It's called the natural exponential function, and it is defined by saying e to the x, or f of x equals e to the x. And again, notice I have that numerical base, and I have that variable for an exponent. So just to answer this one final question before the video is over, what 2 functions should e to the x fall between? Well, because e is defined to be 2.718, then e to the x should fall between 2 to the x and 3 to the x, since e falls between 2 and 3. So I'm going to go ahead and say 2 to the x is going to be less than e to the x, which should be less than 3 to the x. From here, we're now going to we're going to jump right into some application pieces with exponential functions. We're going to talk about how they can be used in oftentimes in financial literacy or in banking situations. And then we'll start moving into other areas where we also see exponential functions, and we'll be writing some of our own equations versus using some interest formulas.